So this is the angle phi that goes here, and this is a phase. This is the excitation or frequency of the wall, capital omega. And omega n is the natural frequency of the system of this. So you already know that omega n is square root of k over m. And you know zeta as well, defined in chapter 2, list of symbols. So in case you have a wall vibrating and you have a spring and a dumper attached to this mass, then following this equation, you know how this mass vibrates, and the vibration of this mass is described by this solution and this phase angle that goes into the sine term. So the key thing to remember from here is that if you have the wall being vibrating with an amplitude of b, seen here, then your mass is going to be vibrating with the amplitude of b multiplied by this amplification factor. So this amplification factor becomes higher when your omega gets close to omega n, or when your zeta becomes very small. When your omega becomes close to your omega n, this term goes close to 0. So this is at the denominator, so this term gets higher, and the overall amplitude gets higher. So when you have resonance, your wall is going to be vibrating, and your mass is going to be vibrating a lot more than if you didn't have resonance.